Various polarization processes. Today we are going to learn 5.2, that is, it is dielectric materials. In dielectric materials, various polarization processes. There are four types of polarization mechanisms in materials: electronic polarization, ionic polarization, orientation polarization, space charge polarization. First of all, electronic polarization means it is the displacement of positively charged nucleus and negatively charged electrons of an atom in opposite directions on application of electric field. That is, displacement of positively charged nucleus and negatively charged electrons of an atom in opposite direction on application of electric field, resulting in electronic polarization. Electronic polarization alpha is given by 4 pi epsilon naught r cube. Units are farad meter square. It is also given as electronic polarization is also epsilon naught er minus 1 by n, where n is number of molecules per unit volume. It is present in all substances. Electronic polarization is present in all substances, independent of temperature, proportional to volume of the atom, fastest of all remaining ionic orientation space charge. It is fastest, occurs up to optical frequencies and is complete. It occurs up to optical frequencies. Next, second is ionic polarization. Ionic polarization is due to the displacement of cations and anions in opposite directions and occurs in an ionic solids. It occurs in ionic solids due to displacement of cations and anions. Alpha I is given by mu by E equal to E naught square by omega naught square 1 by m plus 1 by m, where this is all replaced by 1 m star. E naught square E square by omega naught square in by E square by m star into omega naught square. M star is reduced mass. It is also independent of temperature, slower than alpha E, and occurs only up to infrared frequencies, IR frequencies. Oriental polarization. When electric field is applied to polar molecules, they tend to align themselves in the direction of applied field, giving rise to oriental polarization. This is when we apply electric field to polar molecules tend to align themselves in the direction of electric field, giving rise to oriental polarization. Oriental polarization is alpha naught equal to P naught by Ne. P naught by N equal to mu square by 2 kT. It exists only in polar molecules because it in polar molecules only it exists because they are only oriented in direction of electric field, inversely proportional to temperature, slower, and occurs only up to electrical frequencies. Remember, oriental polarization is electrical frequencies. Next, space charge polarization. Space charge polarization occurs when charges are accumulated at electrodes or at interfaces in material. When accumulation of charge takes place at electrodes, these ions diffuse over distances in response to field. These ions diffuse because of the field. Then there is a chance for redistribution of charges in the electric medium. It is very small in magnitude and hence mostly it is not considered, it is neglected. Which one is neglected? Space charge polarization is not considered mostly. Therefore, total polarization equal to P equal to N alpha equal to Ne into electronic polarization plus ionic polarization plus oriental polarization. This equation P equal to Ne 4 pi epsilon naught r cube B square omega naught square 1 by m plus 1 by m mu square by 3 kT is known as Langevin-Debye equation. And internal fields in solids is given by Ei equal to E plus P by 3 epsilon naught. Clausius-Mossotti relation, which is asked many times in many exams. This equation relates the microscopic parameter, which is microscopic parameter, polarizability is microscopic parameter, with the macroscopic parameter dielectric constant as Er minus 1 by Er plus 2 equal to N alpha E by 3 epsilon. I have already told what is N. N is number of molecules per unit volume. Using this relation, if alpha naught alpha E is given, we can obtain Er relative permittivity. If Er is given, dielectric constant is given, we can obtain alpha naught. Thank you.